All right, class, we're going to be working on lesson 5-2, Congruent Triangles. We will solve problems involving corresponding parts of triangles. You've got these two IXLs related to it. Let's start off with a little bit of review. Can you correctly identify and apply the surface area equations for these basic solids? I've already provided the name of each shape. Take a minute to try out number 7 here first. See if you can find out its surface area. Pause the video. Alright. To deal with this triangular prism, we need to focus first on the fact that we have a triangular base. This name tells you what the base is supposed to be. Our surface area for this triangular prism is supposed to be twice the area of the base. Capital B stands for the area of that triangle plus the perimeter of the triangle times h, the height between the two triangles. We're going to find the area of that triangle first. We're going to find the area of our triangle we're going to have the area is 1/2 the height of the triangle times the base length of the triangle. 1/2 times 2.4 times 3.2. For the perimeter, we're going to find the distance around, this orange distance around the triangle, by adding up all the side lengths of the triangle. The perimeter of this orange triangle will be 2.4 plus 3.2, because we go 2.4 and 3.2. And then we have this 4 is also up here as well, plus 4. Meaning our perimeter will be those three sides added together, just like any perimeter is the side lengths added together. Let's just go ahead and do the area calculation. 1/2 of 2.4 times 3.2 gives us an area of 3.84. The perimeter, 2.4 plus 3.2 plus 4, is 9.6. We can start plugging things in. Our surface area should be twice B. B is the area of that base, 3.84, plus the perimeter, 9.6, times the height. H is normally called the height. In this case, it's the distance from one triangle to the next. How far apart are those two triangles? We see the distance between one triangle and the next is 2 centimeters. We just need to evaluate this. 2 times 3.84 is 7.68. 9.6 times 2 is 19.2. We add them together. We get 26.88. Now it helps you to think about what was the units we want here. We were finding areas, the area of each base. You can approach it by finding, since we're finding areas, we're finding a square shape generally. It's going to be centimeters squared for our units. We have to think about the area. Capital B is the area of the base shape. P was the perimeter of that base shape. Perimeter is the distance around the shape. Area is the space inside the shape. Take a minute to try the same thing with the cylinder here. Hopefully you've made an attempt. The way to go about this is we'd want to start off by identifying the base shape of the cylinder. The base shape of the cylinder, as I'm sure you can tell, is the circle. So we're going to find its area of a circle, which is pi r squared. We're going to find the perimeter, or the circumference of a circle, which is 2 pi r. These are from your reference sheet. You can know those from your reference sheet. We're going to do pi times the radius is 6 squared, and we'll have 2 times pi times 6 here. I'm going to leave it as it is for a bit. You could do the direct calculations, but it's going to be easier if we leave it with pi for a bit. The area would be 36 pi. The perimeter would be 12 pi. The height is the distance from one cylinder to the next. From one circle to the next, we see it's 13. You can start plugging things in. 2 times the area, 36 pi, plus the perimeter, 12 pi, times the height of 13. We can multiply 2 times 36 to get 72 pi. You can do 12 times 13 to get 156 pi. Add those together, we get 228 pi, which, if we then properly do on a calculator, 228 pi is 716 we'll say 28, and we're sort of rounding off there. Since it was area, we'd be measuring this, in this case, inches squared. That was our review of finding surface area. We're going to do our 2 essential questions. These essential questions are for our lesson today on congruent triangles. We've got corresponding parts of congruent triangles are congruent. If 2 triangles are congruent, you want to know what is the relationship between their corresponding, let's say, matching parts. The simple relationship is corresponding parts of congruent triangles are congruent. This is a key phrase you want to have written down. This is a key phrase you want to have written down. It's commonly abbreviated as CPCTC. It's super common in proofs. You'll see it in the future when we're proving triangles are congruent. We're proving parts of triangles are congruent. When we're given only the names of 2 congruent triangles, how can we identify the corresponding parts of the triangles? What's going to be important is that the order of the vertices in the triangle names indicates the corresponding points and the parts. We'll see this in example 2. And a little bit of example 1. On example 1, we're just identifying the corresponding parts, and we're going to use that to help name our triangles. Let's see what we identify first off. On this triangle, I see J to K is 28 meters, and I'm going to look over here to see what other side length is 28 meters. I see G to F is 28 meters as well. So we can mark those as being congruent using the tick marks, because they are. And let's write JK is congruent to GF. We could do the same thing with the other sides. K to I is 13. And what side over here is 13? Well, F to E is 13. So we'll write that as being congruent as well. We'll also see I, and let's mark that with 2 tick marks, saying that ki is congruent to e to f. We see j to I is 31. We see g to e is 31 as well. So we could write ji is congruent to ge. And I'll mark that with 3 congruent tick marks, indicating this side is congruent to this side. We could also talk about the angles as well. J is 25 degrees. G is 25 degrees, so angle G is congruent to angle J. We see angle K is 90 degrees here. We've got a right angle symbol here. It is 90 degrees. We see angle F has a right angle symbol, so it is also 90 degrees. So angle K is the same as angle F. We see angle I is 65. We see angle E is 65. So angle I is congruent to angle E. We can mark those using arced congruency marks. I'm not going to put a congruency mark in the right angle because I don't need to mark right angles congruent. All right angles are always congruent. Now we're being asked to write a congruence statement for the triangles. Basically, if we name one triangle, how do we name the other triangle so that parts match up? It helps to just start off by naming one of the triangles. So let's name this one, we'll name it JKI. We'll name it triangle JKI. Now it's important to pay attention to how you name your triangle, because how you name this triangle is going to affect how you name this triangle. We started at J, which had one angle mark at 25 degrees. We went along the side to the 90-degree angle, which had, that side had the 1 tick mark, and from the 90-degree tick, we went to the 65. We want to make the same path on this second triangle. So let's start. J was where we started. What angle is equivalent to J in this picture? G. So we're going to start off with naming it G, triangle G. We went from G to K, following the side that has 1 tick mark and ending at the 90-degree angle. So from G, we're going to follow the side that has 1 tick mark, ending at the 90-degree angle, F. So we went from J to K, we went from G to F. We then went from K to I, following the side that has 2 tick marks, and we went from the right angle to the 65 degrees. F is the 90-degree angle. We want to follow 2 tick marks to the 65 degrees, and that's going to bring us to E. We named our triangle JKI, and since we followed the same path, GFE should be the congruent triangle name that we want. It's important how we name this triangle. The parts here, J to K, have to match with G to F. And that's what we're looking for here, J to K, G to F. The order of the vertices indicates the naming of corresponding points and parts. We can look at this and say JK is the same as GF. We see it up here. You can see KI is the same as FE. We see it up here. We see JI is the same as GE. JI is the same as GE. We see it there. Now, how do we use that? We can use it to identify matching parts. KJI is congruent to VTU. we want to know what the measure of angle J is. So here's J. Notice it's right in the middle of the name. Let's find the matching letter in the middle of the name, T. T is 55 degrees. J has to be 55 degrees as well. The measure of angle J is equal to 55 degrees. T to V, we have our notes done for today.